This is a solution video for text and test 4, page 445, question 12. And in this question, we're looking for the intersection point of circles. So in this question, I've got two circles and I want to first of all figure out their common tangent. Now I do this in the exact same way as I find the common chord. And it's like doing a simultaneous equation with the two circles. So I'll times one of the circles by -1. It doesn't matter which one. And then I'll be able to cancel off. So the x squareds and y squareds are gone. And then I'll put 14x plus 4x, making 18x, minus 10y minus 14y gives minus 24y, and finally minus 26 minus 28 is minus 54, and I've got equals 0 on the end. This looks a little bit clunky, so I'm actually going to divide this across by a common factor to make it a bit more manageable in the next bit of the question. So let's have a look. What will go into everything? Well, 6 will go into all of these terms, so I'll divide by 6. And then I'll have 3x minus 4y minus 9 equals 0. So this is the tangent that I had to find. So what's going on here is that I've got two circles. They meet at one point, and they've got a common tangent like I've shown in the sketch. And now I want to find the point at which they meet. So all I have to do is take the equation of my tangent, which we just found, and the equation of either of the circles, and do a simultaneous equation with a tangent and a circle. I only have to do it with one circle because they clearly all meet in the same place. So I'm just going to use the first circle. And now I'll go through the usual steps for figuring out where a circle and a line intersect. So the first thing that I have to do is rewrite the line equation. Now, it's a bit of a nuisance this time because I've got coefficients on both the x and the y, so I'm going to end up with a fraction. I can't avoid it. So doing this step by step, I'm going to try and get x by itself. So I'll first of all get 3x by itself, taking the minus 4y minus 9 across the equal sign, making it 4y plus 9 over there. And then to get x, I'll just bring the 3 across and divide. So here's my rewritten line. And now I'm going to sub that into the circle. So everywhere that I have an x, I'll replace it now with this 4y plus 9 over 3. So that's my x squared done, plus the y squared from that equation, plus 14 times 4y plus 9 over 3, because that's 14x getting subbed in for, minus 10y minus 26 equals 0. And now I've got to do a bit of tidying up. So I'm not going to do all the ins and outs of the multiplying out of this bracket here. What I would suggest is that you go off and do a bit of rough work yourself for this. Remember that if you're squaring a bracket, you're multiplying it by itself. And since this is a fraction, I'd have to multiply the top by itself and the bottom by itself. So when I square that out, I should be getting 16y squared plus 72y plus 81 over 9. And then I continue on with the rest of the equation. So I've got my y squared in, and now I must times my fraction by 14. And just note that I'm just multiplying the numerator by 14. So it'll stay over 3. And then I've got my two other terms as well. And I'm not loving the fact that there's fractions in this, so I'm going to try and get rid of all of that. And I can do that by multiplying the whole equation across. Now I'll just take a second to have a look and see what it makes sense to multiply by. So I could multiply by 3, but that wouldn't fully get rid of the 9. But if I multiply by 9, well, that's going to take care of this guy, and it'll also take care of this. So what will that mean then for my equation? Well, I'm going to multiply this whole first fraction by 9. And since I'm multiplying it by 9 and it has a denominator of 9, well, effectively the 9's cancel out. So I'm just left with the numerator. Then I've got my y squared. And now next I've got this fraction. And again, I'm going to times this by 9. But notice how it's being divided by 3 already. So 9 divided by 3, I'm really multiplying by 3. So that'll give me 168y plus 378. And then my last two terms just get times by 9. Right, so a bit of tidying up now is in order. So put the y squareds together, put the y's together, and then put the constants together. And I was having a good look at this quadratic thinking, oh my God, this looks absolutely horrible. And wondering, had I done it correct? And I looked back and I actually found a mistake that I've made on this line here. And I wonder, if you pause the video here, could you figure out what my mistake is? I forgot to multiply my y squared by 9. Very clever. So in goes that 9 there. And then I must just change this here at the very start. Right, that looks a lot nicer. And it looks nicer particularly because I've got a common factor now in all these terms, and I can actually divide across and make this quadratic so much simpler. So I can divide right across by 25. And I end up with this lovely looking quadratic, y squared plus 6y plus 9 equals 0. And now my next job is going to be to factorize and solve this. So this is a pretty straightforward quadratic to factorise, and just bear in mind that I'm expecting to get the same answer twice, and that's because the line only meets the circle at one point. And when I factorise, that's exactly what happens. I get this repeating result of -3, indicating that, yeah, in fact, the line does only meet the circle in one spot. And we're nearly there. All that's left to do now is just to find the x value to go with that. And the easiest way to get that is to go back to my rewritten line here and just use that to substitute the y into. So subbing in there, I get a result of -1. And then of course I've got my x and it has to go with my y to make the point of intersection. And my point of intersection is -1, -3. And just do watch out when you're, put my 25 back in place there. Do watch out when you're multiplying out across a big long equation like this, because it is really easy to go wrong, as you've just seen. And if you do, it could end up sending the whole thing completely haywire. So just take your time.